Silver, once primarily ornamental, is now indispensable in modern technologies due to its unparalleled electrical and thermal conductivity, antimicrobial properties, and corrosion resistance. This video examines silver's critical applications in AI, electric vehicles, solar photovoltaics, and defense systems, drawing on 2024 data from the Silver Institute's World Silver Survey. Photovoltaics stands out as the sector with the highest silver consumption, reaching 197.6 million ounces in 2024. While silver remains irreplaceable in many uses, innovations in alternatives like copper metallization and alloy substitutions offer potential mitigation strategies. However, full replacement timelines extend beyond 2030 due to performance trade-offs, underscoring silver's strategic importance amid global electrification and technological advancement. Silver's unique physicochemical properties, including the highest electrical conductivity among metals, superior reflectivity, and natural antimicrobial efficacy, make it a cornerstone of 21st-century innovation. Historically, photography and jewelry dominated silver demand, but industrial applications now account for over 58% of global consumption, totaling a record 680.5 million ounces in 2024. This surge reflects the metal's integration into green technologies and high-performance electronics, driven by the energy transition and digital revolution. Global silver demand reached 1.16 billion ounces in 2024, a 3% decrease from 2023's peak, yet still elevated due to robust industrial uptake. Mine production grew modestly by 0.9% to 819.7 million ounces, perpetuating a multi-year supply deficit of approximately 184 million ounces. Key drivers include the photovoltaic boom, EV proliferation, AI infrastructure expansion, and escalating defense needs. AI's exponential growth, projected to double semiconductor production by 2027, amplifies silver demand for high-conductivity components in data centers, edge devices, and semiconductors. Silver enables ultra-low resistance interconnects, bonding wires, and multilayer ceramic capacitors in AI chips, where even marginal efficiency gains translate to massive energy savings. In broader electronics, silver paste and coatings ensure reliable signal transmission in 5G antennas, sensors, and printed circuit boards. The electronics sector consumed 445.1 million ounces in 2023, with AI contributing to a 20% year-over-year rise, and is forecasted to exceed 456 million ounces in 2025. Semiconductor packaging alone accounts for 18 to 22% of electronic silver use, concentrated in AI accelerators and high-performance computing. AI-related demand is structural, with silver's irreplaceability in high-reliability applications ensuring sustained growth at a 13% CAGR through 2030. Electric vehicles demand silver for efficient power management, leveraging its conductivity in inverters, bus bars, charging contacts, and battery interconnects. Battery electric vehicles require 25 to 50 grams of silver per unit, 1.5 to 2 times that of internal combustion engine vehicles. With global EV sales hitting 17 million units in 2024, automotive silver consumption reached approximately 80 million ounces, projected to approach 90 million ounces by 2025. Emerging solid-state batteries could escalate this further, potentially adding 16,000 metric tons annually if adopted in 20% of EVs by 2030. Inductive charging coils and autonomous driving sensors compound needs, with silver enabling corrosion-resistant high-voltage connections. Photovoltaics represents silver's fastest-growing application, consuming 197.6 million ounces in 2024, which is 29% of industrial demand, and up 77% from 2022. Each panel embeds approximately 20 grams of silver, facilitating electron collection and grid lines for 20 to 25% efficiency. Projections indicate 546 million ounces by 2030, potentially 20% of total silver demand, as N-type cells require higher loadings for superior performance. TOPCon technology, with 120 milligrams per cell, holds 85% market share in 2024 and is projected to consume over 400 million ounces by 2030. Silver's role in defense is opaque due to classification, but its conductivity and durability underpin missiles, torpedoes, submarines, and drones. Missiles can contain 0.5 to 2 kilograms per unit in guidance systems, torpedoes 5 to 50 kilograms in AGSN batteries, and submarines 3 to 8 tons per unit. Night vision, radar, and avionics, such as in F-35 jets, rely on silver for EMI shielding and thermal dissipation. U.S. agencies ceased inventory reporting in 1996, fueling speculation of underreported demand potentially rivaling industrial totals, estimated at 10 to 50 million ounces per year. Global military spending hit $2.7 trillion in 2024, a 9.4% year-over-year rise, with hypersonic missiles and AI-integrated systems accelerating uptake. Batteries, integral to EVs and grid storage, use silver in advanced chemistries like AGZN and emerging solid-state variants. The electronics and battery subsector hit 231.6 million ounces in 2024, reinforcing silver's approximately 700 million ounce industrial footprint. Among queried sectors, photovoltaics emerges as the preeminent consumer, devouring 197.6 million ounces in 2024. This surpasses electronics, which consumed approximately 250 million ounces including AI, when isolating PV-specific use. It also dwarfs EVs, which consumed approximately 15 million ounces, and defense, estimated at less than 50 million ounces. Substitution efforts are underway due to cost pressures, with copper or nickel plating and graphene inks being explored for electronics and AI. These alternatives are feasible by 2027 to 2030, but with a 10 to 20% efficiency loss, delaying widespread adoption. For EVs and batteries, aluminum or copper busbars and silicon anodes are alternatives, with solid-state shifts to silver-free electrolytes possible post-2030. In solar PV, copper electroplating or nickel pastes or perovskite tandems could eliminate silver, with full copper replacement viable by 2026 to 2028. Recycling accounted for 193.9 million ounces in 2024, up 6%, helping to bridge supply gaps. Silver's 2024 consumption underscores its linchpin status in AI, EVs, solar, and defense, with photovoltaics as the voracious leader at 197.6 million ounces. As demand nears 1.2 billion ounces in 2025, supply deficits risk escalation unless substitutions accelerate, particularly copper in PV by 2028 and alloys in electronics by 2030. Policymakers must prioritize recycling and R&D to avert bottlenecks, ensuring silver's legacy evolves from scarcity to sustainability. Future research should model geopolitical impacts on defense demand for holistic forecasting. Please subscribe to China Tech Chamatkar for such tech-related analysis on various modern technologies which affects us.